Assalamu alaikum, dear students, class 9th. Our today's lecture is about matrices again, and it's exercise 1.2. We are going to start it. The first question is, from the following matrices, identify unit matrices, row matrices, column matrices, and the null matrices. I told you about the unit matrices. What are the unit matrices? If in a matrix we have all the entries 0, just like this, and in a diagonal the 1 is appearing, then it's called a unit matrix, or we can say identity matrix. What is row matrix? Row matrix is a matrix having only one row, but the columns can be 2 or more than 2. Like this matrix having only one row, but the columns can be 2 or more than 2. Then it comes to column matrix having one column, but the rows can be more than 2 or it can be 2. We are not going to do anything with the number of rows. When we are questioned about the column matrices, then we are nothing to do with the number of rows or anything else. We will just focus on the columns, that how many columns does it have. If the matrix have one column, then it would be a column matrix. Similarly with the row matrix. And then the last one is null matrix. Null means nothing. So null matrix having the matrix having 0 0 0 0 as its entries. Okay, so let's go to the categories and point out the different type of matrices. The first one is A equals to 0 0 0 0. All of the entries are 0, so it's a null matrix. Okay, it's a null matrix. The second one has only one row, so it's a row matrix. The third one is column matrix. The fourth one is identity, or we can say unit matrix, because all of the entries are 0 except the diagonal, and the diagonal have 1. So it's an identity matrix or unit matrix. What about this matrix? It's null. Yeah. Why it's null? Because 0 is its only one, the single entry, and it's row because having only one row. It's also the column matrix. Why? Because it has only one column. What about this one? It's a column matrix. Now we will do the question number 2. I am not going to write the question, just telling you, reading it out. From the following matrices, identify square matrices, rectangular matrices, row and column matrices, identity and null matrices. Okay, the first one is -8, 2, 7, 12, 0, 4. The second one is 3, 0, 1. The third one is 6, -4, 3 and -2. The fourth one is 1, 0, 0, 1. The fifth one is 1, 2, 3, 4, 5, 6. The sixth one is 3, 10 and -1. Moving further, the seventh 1, 0, 0. The eighth 3 cross 3 matrix, 1, 2, 3, -1, 2, 0 and 0, 0, 1. and the last one is 0 0 0 0 0 0. So the first one is a rectangular matrix. How can I say that? Because the number of rows are 2, the number of columns are 3. It's 2 by 3 matrix. So it's a rectangular matrix. Okay? What about the second one? It's a column matrix because number of rows are 3 but the number of columns is 1. It's a column matrix. Then it comes to 6 minus 4, 3 minus 2. What about this? It's a 2 cross 2 matrix. So it's a square matrix. Sorry. Number 4. As you can see, I have discussed it in question number 1. D is that part. Identity matrix. Why? Because it's a square matrix having only entries in the diagonal and they are 1. So it's identity matrix. About 5th, number of rows are 3 and number of columns are 2. 3 by 2 matrix. It's a rectangular. Yeah, these both are. This and this. These both are rectangular. About this matrix, the row is 1 but the columns are 3. 1 cross 3 matrix. It's a row matrix. Then it comes to this one. It's a column matrix because it is having only 1 column. 3 rows and 1 column. It's a 3 cross 3 matrix. Number of rows and number of columns are equal. So it's a square matrix. Last. 0 0 0 0. All of the entries are 0. It's a null matrix. We discussed it. Moving to the question number 3. From the following matrices, identify diagonal. And then identify scalar and identity matrices. Just for practice. You already did it. The first one is 4004. We are going to identify it as a scalar or unit or diagonal. First, you should know that what is diagonal, what is scalar, and what is identity matrix. So students, diagonal matrix is a matrix having all of the entries 0 except the diagonal. There must be one non-zero entry in the diagonals as I discussed previously. So the first one is the diagonal matrix. What about the scalar? The scalar matrix is the type of matrix having same entry in the diagonal. Same entry in the diagonal. So which one among these is the scalar? I guess we have to simplify it first. 5 minus 3 is 2, 0, 0, 2. This one is the scalar matrix. Why? Because it has same number of entry in its diagonal and all other entries are 0. So it's a scalar. What about this one? It's a diagonal matrix. I discussed it. Why is it? Identity matrix. And this one is diagonal 2. Because in the definition of diagonal matrix, there must be one single non-zero entry in the diagonal. This is the diagonal of the matrix and it has one non-zero entry. So it's a diagonal matrix. Question number 4. Find negative of matrices A, B, C, D and E when A equals to 1, 0, minus 1. Negative of A would be represented by minus A. And we are going to multiply minus with every single entry of the matrix, or you can say you are going to change the sign of every single entry of the matrix. Minus A, 1 would be changed into minus 1. 0, we can never use the minus negative sign with 0. 0 is always a neutral. Then minus 1, it would be changed into positive 1. Okay, the next matrix B. 3 minus 1, 2, 1. Negative of B is minus 3, positive 1. Minus 2, negative 1. Okay, now we are going towards C. 2, 6, 3, 2. The negative of C would be minus 2, minus 6, minus 3, minus 2. Okay, so for the D, we are going to write minus D. And in minus D, minus 3 would be changed into 3. 2 would be changed into minus 2. Minus 4 would be changed into 4. And 5 would be changed into minus 5. The last one is E. 1, minus 5, 2 and 3. Minus 1, positive 5, minus 2, negative 3. All are done. Now we will move to the question number 5. Find the transposes of each of the following matrices. Yeah, we are going to find the transpose. What is transpose? Transpose is basically rows changing into columns and the columns changing into rows. It is denoted by AT. If A equals to 0, 1, minus 2, then the transpose would be denoted by this and it would be changed. The whole of the column will move horizontal. This is the transpose of A. Now we will do the transposes of B, C, 1, 2, 2, minus 1, 3, 0. This is the C. And D is a 2 cross 2 matrix having these entries. Okay. So the transpose of B is the whole of the row which is horizontal will be moved vertical. This is the transpose. For C, first row, first column, second row, second column, third row, third column. D, the transpose of D, 2, 3, vertically, 0, 5, then they would be also written vertically. Okay, so this is what the transposes of ABCD were. Now I will tell you about EF. What is the matrix E? 2 minus 4, 3, 5. And the matrix F, 1, 2, 3, 4. Okay, so its transpose would be 2, 3 minus 4, 5, 1, 2, 3, 4. The horizontal will be changed into vertical. Okay, if you have any queries about it, you will let me know. Now question number 6. Verify that if A equals to 1201 and B equals to 1120, then A transpose and again transpose is equal to A. The double transpose of A would be equal to A. A equals to what? 1201. And we are going to verify that A transpose A equals to A. First, we are going to take transpose of A. The rows are going to be changed into columns. Step. Now I am going to take the again transpose of this. This indicates that we are going to take 2 times of transpose of the matrix A. So that would be 1, 0 again change into vertical. Horizontal will change into vertical, or you may say rows are going to change into columns. For B, what is the matrix B? 1, 1, 2, 0. B transpose 1, 1, 2, 0. The rows are going to be changed into columns. Again transpose of B. 1, 2 is going to be changed like this. 1, 0 is going to be written like this. And here is what the magic happens. The double transpose of B is equal to B. You can compare 1, 1 in a first row, 1, 1 in a first row, 2, 0 in the second row, and 2, 0 in the second. Similarly here, matrices is a most interesting chapter you have in your 9th class books. So, dear students, exercise 1.2 is all done. If you have any queries related to this, you will let me know. I will be there for you, inshallah. हमेशा जहाँ रहिए, खुश रहिए, हंसते मुस्कुराते रहिए, and please subscribe my channel and press the bell icon so that if I enter the new video, then you will know about it. And you will give me the comments about it. Thank you. Allah Hafiz.